A hydrometer is an instrument that measures the specific gravity of liquids, the ratio of the density of the liquid to the density of water. A hydrometer is usually made of glass and consists of a cylindrical stem and a bulb weighted with mercury or lead shot to make it float upright. The liquid to test is poured into a tall container, often a graduated cylinder, and the hydrometer is gently lowered into the liquid until it floats freely. The point at which the surface of the liquid touches the stem of the hydrometer correlates to specific gravity. Hydrometers usually contain a scale inside the stem, so that the person using it can read specific gravity. A variety of scales exist for different contexts. Hydrometers are calibrated for different uses, such as a lactometer for measuring the density of milk, a saccharometer for measuring the density of sugar in a liquid, or an alcoholometer for measuring high levels of alcohol in spirits. Principle. Operation of the hydrometer is based on Archimedes' principle that a solid suspended in a fluid is buoyed by a force equal to the weight of the fluid displaced by the submerged part of the suspended solid. Thus, the lower the density of the substance, the farther the hydrometer sinks. Thus, it is based on the principle of flotation. History. An early description of a hydrometer appears in a letter from Synesius of Cyrene to the Greek scholar Hypatia of Alexandria. In Synesius's 15th letter, he requests Hypatia to make a hydrometer for him. Hypatia is given credit for inventing the hydrometer sometime in the late 4th century or early 5th century. The instrument in question is a cylindrical tube, which has the shape of a flute and is about the same size. It has notches in a perpendicular line, by means of which we are able to test the weight of the waters. A cone forms a lid at one of the extremities, closely fitted to the tube. The cone and the tube have one base only. This is called the beryllium. Whenever you place the tube in water, it remains erect. You can then count the notches at your ease, and in this way ascertain the weight of the water. According to the Encyclopedia of the History of Arabic Science, it was used by Abu Rayhan al-Biruni in the 11th century and described by Al-Khaziani in the 12th century. It later appeared again in the work of Shak Alexander Ce Acute Sar Charles in the 18th century. Ranges. In low-density liquids such as kerosene, gasoline, and alcohol, the hydrometer sinks deeper, and in high-density liquids such as brine, milk, and acids it doesn't sink so far. In fact, it is usual to have two separate instruments, one for heavy liquids, on which the mark 1.000 for water is near the top of the stem, and one for light liquids, on which the mark 1.000 is near the bottom. In many industries a set of hydrometers is used, covering specific gravity ranges of 1.0 to 0.95, 0.95 to 0.9 etc., to provide more precise measurements. Scales. Modern hydrometers usually measure specific gravity, but different scales were used in certain industries. Examples include API gravity, universally used worldwide by the petroleum industry. Baume scale, formerly used in industrial chemistry and pharmacology. Brix scale, primarily used in fruit juice, winemaking and the sugar industry. Oechsler scale, used for measuring the density of grape must. Plato scale, primarily used in brewing. Twaddle scale, formerly used in the bleaching and dyeing industries. Specialized hydrometers. Specialized hydrometers are frequently named for their use. A lactometer, for example, is a hydrometer designed especially for use with dairy products. Lactometer. A lactometer is used to check purity of cow's milk. The specific gravity of milk does not give a conclusive indication of its composition, since milk contains a variety of substances that are either heavier or lighter than water. Additional tests for fat content are necessary to determine overall composition. The instrument is graduated into 100 parts. Milk is poured in and allowed to stand until the cream has formed. Then the depth of the cream deposit in degrees determines the quality of the milk. The device works on the principle of Archimedes' principle that a solid suspended in a fluid is buoyed by a force equal to the weight of the fluid displaced. If the milk sample is pure, then the lactometer floats on it, and if it is adulterated or impure, then the lactometer sinks. Alcohol meter. An alcohol meter is a hydrometer that indicates the alcoholic strength of liquids. It is also known as a proof and trowels hydrometer. It only measures the density of the fluid. Certain assumptions are made to estimate the amount of alcohol present in the fluid. Alcoholometers have scales marked with volume % so of potential alcohol, based on a pre-calculated specific gravity. A high potential alcohol reading on this scale is caused by a greater specific gravity, assumed to be caused by the introduction of dissolved sugars. A reading is taken before and after fermentation. An approximate alcohol content is determined by subtracting the post-fermentation reading from the pre-fermentation reading. Saccharometer. A saccharometer is a hydrometer used for determining the amount of sugar in a solution, invented by Thomas Thomson. It is used primarily by winemakers and brewers, and it can also be used in making sorbets and ice creams. The first brewer's saccharometer was constructed by Benjamin Martin and initially used for brewing by James Baverstock Sr. in 1770. Henry Thrale adopted its use, and it was later popularized by John Richardson in 1784. It consists of a large weighted glass bulb with a thin stem rising from the top with calibrated markings. The sugar level can be determined by reading the value where the surface of the liquid crosses the scale. It works by the principle of buoyancy. A solution with a higher sugar content is denser, causing the bulb to float higher. Less sugar results in a lower density and a lower floating bulb. Thermo Hydrometer. A thermohydrometer is a hydrometer that has a thermometer enclosed in the float section, for measuring the density of petroleum products, like fuel oils. The specimen is usually heated in a temperature jacket with a thermometer placed behind it, since density is dependent on temperature. Light oils are placed in cooling jackets, typically at 15 degrees Celsius. Very light oils with many volatile components are measured in a variable volume container using a floating piston sampling device to minimize light end losses. At a battery test, it measures the temperature-compensated specific gravity and electrolyte temperature. Urine Ometer. A urinometer is a medical hydrometer designed for urinalysis, as urine's specific gravity is dictated by its ratio of solutes to water. A urinometer makes it possible to quickly assess a patient's overall level of hydration. Barcometer. A barcometer is calibrated to test the strength of tanning liquors used in tanning leather. Battery hydrometer. The state of charge of a lead-acid battery can be estimated from the density of the sulfuric acid solution used as electrolyte. A hydrometer calibrated to read specific gravity relative to water at 60 degrees Fahrenheit is a standard tool for servicing automobile batteries. Tables are used to correct the reading to the standard temperature. Antifreeze test. To another automotive use of hydrometers is testing the quality of the antifreeze solution used for engine cooling. The degree of freeze protection can be related to the density of the antifreeze. Different types of antifreeze have different relations between measured density and freezing point. Acidometer, sometimes spelled acidometer. An acidometer is a hydrometer used to measure the specific gravity of an acid. Use in soil analysis. A hydrometer analysis is the process by which fine-grained soils, silts and clays, are graded. Hydrometer analysis is performed if the grain sizes are too small for sieve analysis. The basis for this test is Stokes' law for falling spheres in a viscous fluid in which the terminal velocity of fall depends on the grain diameter, and the densities of the grain in suspension and of the fluid. The grain diameter thus can be calculated from a knowledge of the distance and time of fall. The hydrometer also determines the specific gravity of the suspension, and this enables the percentage of particles of a certain equivalent particle diameter to be calculated.